What I'm about to do here is I'm about to take this equation right here, which is a quadratic equation, which of course is going to graph a parabola, and I want to determine what it is in vertex form, right? So thinking about what vertex form is, vertex form generally looks like this, where y equals a vertical stretch or compression factor of a that times is with the quantity of x minus h squared plus k, right? So a form that we've worked with very frequently. So in order to actually write something that's in vertex form, it requires the use of completing the square to be able to write a parabola in vertex form. So here's how this is going to work and operate for us. So I'm just going to go ahead and copy the equation that we have that's given in standard form right here. Now the constant of -6, I'm going to kind of just slide it over a little bit, so leave a little bit of room in front of it because I'm going to write something there. So what I just need to do is I need to, inside of this red rectangle, really create a perfect square trinomial. And so since there's just a 1 in front of x squared, I can just kind of figure out what I need to complete the square right away. So if I notice that my b value right there is just a 4, I can take half of that, which is 2, and then square it, which would be 4. So what I need is I need to add 4 to complete the square, because then overall this thing right here just factors nicely as x plus 2 times x plus 2, so it's really just x plus 2 squared. Now the thing is though is that if I added in 4 but there's still this -6, then it's actually changed the equation to become x squared plus 4x minus 2 if you added 4 and subtracted 6, which is not the same equation, right? And I don't want to change the equation. I'm just trying to rewrite the equation into vertex form. So what you're going to need to do so that you don't change the equation, so that it's still the same equation, is the fact that you plus 4 needs to also then be undone, and so I would then also minus 4, so it's really not going to change the equation overall. It's still going to be x squared plus 4x minus 6. But then just these numbers on the outside right here, you can combine those together to be minus 10. So then it just turns out that, voila, right there, that gives you the equation in vertex form for the parabola. And it works out really nicely because you can see right here, this is the graph of y equals x squared plus 4x minus 6. And as we know about vertex form, the plus 2 inside of the parentheses right there is going to shift the graph left 2 units, and that's going to shift it down 10 units. So we would expect that the vertex of the parabola is going to be at -2, -10, and as we can see, indeed, it is located right there, -2, -10. Okay? All right, so there's a number of examples that are really, really important and crucial for us to go through in terms of writing different types of quadratic functions into vertex form. So there's nothing really too crazy with the first example here, because it's just like the first one in that there's just a 1 in front of the x squared. So nothing too crazy, but it's just nice to kind of reinforce what we just saw. So you can see that it's the same equation, x squared minus 16x. And then what I'm going to do here is I'm going to try to complete the square right there in that red box that I just drew. So since my b value is a -16, I'm going to take half of that, which is -8, and then square -8, which is 64. So that's what's going to be needed to complete the square. But then I'm going to also subtract 64 to make sure that it stays the same equation. So the plus 64 and -64 will cancel each other out. But it's needed because then right here, this is going to factor nicely as the x minus 8, that quantity squared. And then I can take those two numbers right there, -7 and -64, and combine them together. Gives you -71. And so that gives us f of x, just rewritten, but now into vertex form. All right, so with the last remaining 3 examples, kind of the big thing to notice here as we move into trying to get these into vertex form is that the a values are not 1s, and I have different types of numbers. So we'll start with something that's just a positive whole number, the 3 right there. And then we'll see kind of what happens when we've got a negative a number there. And then finally, a fraction number as an example. Okay, so starting with this fella right here. So if I want to get this into vertex form, it's really nice to complete the square when you've got a 1 in front of x squared, right? So what you're going to need to do is you're going to need to factor out that a number from the first term, and then also from the second term. So it turns out that 3 times -18 is 54. Okay. Now, the other c number, so the 196 in this case, I'm going to write that outside of this parentheses that I wrote, okay? So I want you to just kind of pause and just realize the fact that we still have 3x squared minus 54x plus 196, right? We haven't changed the equation at all. So all that I just kind of need to happen at this point is that this right here, I want to make it a perfect square trinomial. So I'm going to try to add in something right here that will make it so. And then whatever I add in right there, I'm going to undo it over here. So I keep the equation still the same, right? So since my b number is negative 18, half of negative 18 is 9, and then 9 squared is 81. So I need an 81 there to complete the square. So what will happen then is that that trinomial will factor as x minus 9 squared. And then of course you have the 3 that's timesing in front of it. Now the thing that you need to realize right here is that when I added an 81, it was actually in the parentheses. And so I actually added in 3 times 81, so I actually really added in 243. So that means out here, I actually need to subtract 243 out there to undo that, to make sure I still have the same equation. So then if I take those couple numbers, positive 196 and negative 243, and combine those together, you end up getting negative 47. So this equation right here gives you the equation then written and expressed in vertex form. All right, so now you kind of get a little flavor of what's kind of happening when we have this a number that's not a 1. So this time it's just a negative, right? So if I'm going to rewrite this into vertex form, I'm going to factor out the negative 2 from the first couple of terms, from that term as well as that term. So that means in the parentheses I'm going to have x squared, and then if I factor out a negative 2 from negative 4x, you end up with a positive 2x inside. And then again, that negative 24, I'm going to write that outside the parentheses. So I want to try to complete the square right here. So if I've got a b value of 2, then half of 2 is 1, and 1 squared is 1. So I need to add in a 1 to complete the square there. So then I need to undo that, and really actually what I did is I'm actually subtracting a 2 right there when I distribute. So I actually need to add 2 right there to undo the subtracting of 2 that actually kind of occurred right there. And then, yeah, then you're able to then actually factor. This is x plus 1 times x plus 1, so x plus 1 squared. And then you take those couple numbers of negative 24 and 2 and add those together, and you get negative 22. And that is that equation right there, rewritten into vertex form. And then finally, one last one. This is where we'll move to the one that's got that fraction in front as an a value. So again, you're going to want to take that a value and factor it out from the first couple of terms. So if you factor out from x squared, you'll get just x squared in parentheses. And then you actually need here something that's bigger than 5. If you took out a 1/3, something that's smaller than 1, you actually need a 15x right there, because 1/3 of 15 would give you still 5 there. And then I'm going to close off the parentheses there and then put the plus 61 on the outside of that, okay? All right, so we actually do get a value right there, that 15, that is an odd number, right? So if I do take half of it, you're going to get like a fraction, 15 halves, and then if you square it, you're going to actually have to add 225 fourths is what 15 squared is. So it turns out that we're not actually really adding 225 fourths overall, because what we're adding into the mix here is what 1/3 of 225 fourths is. So in other words, we're really adding in 225 twelfths, okay? Now, if you plug that into a calculator and you wanted a decimal for that, that is also the same thing as 18.75. So you can just kind of think then, okay, well, we could subtract 18.75 then here on the outside to undo the fact that we added that 18.75. So then this fella right here that you circle in blue is a perfect square trinomial. It's going to factor as x plus 15 halves, that quantity squared. Yeah, and then it's multiplied by the 1/3 that's in front of that. And then we can take those couple numbers and combine those together. You're going to end up with 42.25 when you take 61 minus 18.75. Yeah, and then we can just say that that's equal to g of x, but now rather than in the standard form that it originally was given in, it gives it in vertex form now there.